Guys, so we're going to start to talk about absolute value functions in this last day of notes for Unit 1. So you have in this example the absolute value parent function y equals the absolute value of x. So it's important to remember that when you're working with absolute value functions, that remember the absolute value of a number, for example, the absolute value of 3 is 3. It is the distance from 0. So the absolute value of any number is the distance from 0. So the absolute value of, say, -3 is going to also be 3 because it is 3 units from 0. Okay, so let's try plugging in these numbers and get an answer. So in this first one, we've got -2. So the absolute value of -2 is 2. Absolute value of -1 is 1. Absolute value of 0 is 0. 1 is 1, and 2 is 2. Now that we have our ordered pairs, let's graph it to see what an absolute value graph looks like. So you have -2, 2 is right here. -1, 1 is right here. 0, 0 is right here. 1, 1 right here. And 2, 2 right here. And if I make a quick little couple lines out of this, you'll notice that an absolute value function graph looks like a V. So whenever you are graphing absolute value functions, you are going to make a V with your graph. Let's start looking a little more closely at what the absolute value functions can look like compared to the parent function. So there's a couple of things to notice about each of these graphs. First of all, the parent function, or the original function that we graphed, is the dotted line. So we're looking at the dotted line and what happened from the dotted line to the red line. So if you look at the first equation, notice that this equation, the difference between this and the parent function is that it has a +2. Okay, now you can tell me what did it do from the dotted to the red. The dotted to the solid line, it went up 2. So that +2 on the outside of the absolute value must mean that you move it up 2. Okay, in the next equation, notice that we have a -3 on the outside here. And if you look at the picture of the graphs, from the dotted to the solid line, it went down 3. So that -3 on the outside must mean that we had to move it down 3. If you look at the next picture of the graph, we have a +3 on the inside of the parentheses. And if you look at the actual graph, in the actual graph, the dotted to the solid, we actually moved left 3. So that tells us that when you see a +3 inside the absolute value, that means move left. So it's kind of opposite thinking. Typically, you would think that you would move to the right, but for this particular absolute value functions, you move to the left when it is inside. Okay, and then notice the last picture of the graph. There is a -2 on the inside of the absolute value, and if you look at the graph, we in fact moved right 2. So the -2 on the inside of the absolute value means right 2. Okay, so these are all the translations of absolute value functions and absolute value graphs. And now we're going to look at the what they give us for an equation, and we're going to do the translating, okay? So it gives us the dotted line is the parent function, y equals the absolute value of x. And in the first equation, notice that it has this +3 on the outside. And if you look back up at our notes, the +3 on the outside means that you are going to move up, okay? So the plus on the outside of the absolute value means you're going to move up. So what you're going to do is you're going to take about 3 of these points. I'm going to put a point here, a point here, and a point here on my original parent function. And all I'm going to do is move all 3 of those points up 3. So I'm going to move one of them up 1, 2, 1, 2, 3 right here. The middle one goes to 3 right here. And the left one goes to 3 right here. And then I'm going to draw my new graph, which again always looks like a V when we're doing absolute value. And there's our final answer. In the next equation, notice that we have a -5 on the inside. So remember, -5 on the inside means we're moving right and left, but it is opposite thinking. So instead of going left, we should go right 5 because of the minus 5. Okay, so again, I'm going to put dots on the 3 original points, and I'm going to move all of those dots right 5. So if I move this one right 5, I'm here. If I move the middle right 5, I'm here. And if I move the last one right 5, I'm here. And of course, we're always going to make this v for our function. Okay? So let's look at the next set of graphs. So the next set of graphs, you may notice, has 2 things to do. So it just takes it one step further, and now instead of doing one translation, we're going to do 2 in 1. So we have to look at the equation first and figure out what we've got. So if I look at the equation, I've got a minus 5 on the inside of the absolute value here, and that tells me to go right 5. I also have a plus 3 on the outside of the absolute value here, and outside tells me to go up or down, so that tells me to go up 3. So what I'm going to do is I'm going to take my original points right here on the parent function, and I'm going to move them all right 5 and up 3. So I'm going to go 1, 2, 3, 4, 5, 1, 2, 3. There's the furthest most point. 5 and 3 brings you here, and 5 and 3 brings you here. Sometimes it's pretty easy once you graph the first point to graph the other points because you know you're going to be making a V. So they're going to be in the same about positions compared to the middle point. Okay? And then in the next one, notice that we have a plus 2 on the inside here, and plus 2 tells you to move left 2. And on the outside, we have a minus, on the outside, we have a minus 3. And minus 3 will tell you to move down 3. Okay, so we're going to take all of our points, our 3 points, and move them up left 2, down 3. So we're going to go left 1, 2, and down 1, 2, 3. Left 2, down 3 right here. Left 2, down 3 will give me a nice V right here. And then you draw your V. Okay, so to summarize all of this, all of these equations, these absolute value equations, are in this form. Y equals the absolute value of x plus or minus h, and then close the absolute value plus or minus k. So this is where h and k are just numbers. They're real numbers. Okay? H and k are real numbers. So when you see an equation like this, what it's really telling you is whatever is on the inside, whatever number is on the inside, so the inside of the absolute value, tells you to move left or right. So whatever is on the inside of the absolute value tells you to move left or right. Whatever is on the outside of the absolute value, so the outside of the absolute value, tells you to move up or down, okay, depending on the sign. And remember, when you're working with the inside of the absolute value, where it's telling you to move left and right, where you're working on the inside, remember it's opposite thinking. So I was going to say think opposite, okay? So if it's a minus 2, you're going to go right, and if it's a plus 2, you're going to go left. It's kind of opposite thinking there. All right, and in the next and in the last part of these notes, you're going to identify how the leading coefficient, so that number that's out front of the absolute value, affects the graph. So if you look at these few examples, in the first one, we have a 2 on the outside of the x. And you might notice that it's similarly written to if it was y equals mx, to a form where it's y equals mx. Okay, it is similar to that. Remember, m is the slope. So in this particular one, our slope is 2 over 1. So notice that from the dotted to the solid, what I did is that my middle point went up 2, right 1. and then we plotted another one, and we plotted one to the left and drew our graph. So that number on the outside really tells you the slope of your absolute value graph, where if you start in your center point, you can just count rise over run, and you'll be able to plot your next point. So same with this next example. Let's look at this next example. Our slope in this next example, our number on the outside of the parentheses is 1/2. So that tells you to move up 1, right 2. So if I look at my graph and I started in the center here, I went up 1 and right 2 and plotted a point, and then the new graph was formed on the solid line. Same with the next one. In this one, we have a -3 this time as a slope. So our slope in this one is -3 over 1, which tells you to go down 3, right 1. So notice that when it is a negative, it ends up flipping, right? It ends up flipping upside down. So from that original point, let's check it out. Let's check to make sure it works. We went down 3, right 1, and we ended up on that solid line to make our new V graph. Okay? So conclusions from all these graphs are that if you have something, an equation, an absolute value equation in the form y equals ax, where a is a number, if the a is positive, so if the a is greater than 0, then if you look at your first example, the graph opens. If a is greater than 0, then the graph opens up, right? If the a is less than 0, if the a is a negative coefficient, so if the a is less than 0, then that gives a graph that opens down, like in the last example that we just did, right? So negative is down, positive is up. That's pretty easy to remember there. But then notice as the coefficient a gets closer to 0, what happens to the graph? So the closest one to 0 here would be this picture, right? Because 1/2 is closer than 2, and it's closer than -3 to 0, okay? So what happened to that graph? It got wider. So the closer that the a is to 0, the wider the graph. And then opposite thinking here with the other one, as the coefficient gets farther from 0, then if you notice, the farthest one from 0 would be this picture of a graph right here. And you may notice that the farther it gets from 0, that the more narrow it gets. So you're going to use these conclusions to determine the answers to an example like this that you're going to see in ALEKS, okay? They're going to give you absolute value functions and the written equations for them, and they're going to ask you which ones open up or down, which one's the widest, and which one's the narrowest, okay? So in the first one, it says for each function, state whether the graph opens up or down. So we're just looking to see if it's positive or negative on the outside. This has a negative on the outside, so this is going to be down. Y equals -2, absolute value of x is going to open down. This next one is going to open up, and this last one is going to open down. So that's pretty easy enough, positive and negative. Then it says to place an x of the function with the widest graph. Well, remember, the widest graph is the one that has an a, or a number out front, that's closest to 0. So out of all these numbers, the one that is closest to 0 is y equals 1/4 x, because 1/4 is the closest to 0, or 1/4 absolute value of x. So our answer there would be this function, okay? And then it says place an x for the function with the narrowest graph. Okay, so again, recall from up here that in order for a graph to be the most narrow, it has to be farthest from 0. So we're looking for the function that is farthest from 0, and the one that's farthest from 0 would be this one, -2, because that's the one that's going to be the furthest away. So our answer there would be that one, y equals -2, absolute value of x. Okay, so when you're going to graph these types of functions, now we are going to combine the translating part that we just learned about just a minute ago, and we're going to combine the coefficient part, okay? So remember that coefficient, or that number out front that we just learned about, okay, refers to the slope. So in our equation, we have a 2 at the front. So our slope is 2 over 1, which tells us we're going to go up 2 over 1. Okay? So in order to graph our equation or our new function now, what we're going to do is we're going to plot the first points using the slope. So from the center point, I'm going to plot up 2 over 1 to the right and up to left 1 so that I can make my V. So far, this is what we've got for our graph. Okay, so always start at the center when you're doing the slope, go up to right 1, up to left 1, and you have your V. Okay, then on the outside here, the translation, we have a -5, which tells you to go down 5. So what I'm going to do is I'm going to move all of my points down 5 from my red graph. So I'm going to go down 5 here, down 5 here, 1, 2, 3, 4, 5, and down 5 here on the other side, so that my final graph looks like this. Okay? All right, let's try the next one. In the next problem, notice that we have a negative on the outside here, which stands for the slope must be -1 over 1, which tells us to go down 1, and then right, I'm going to put right and left 1. So that way you know that you're always going to go right and left when you're making an absolute value graph or when you're graphing it so that you can make your V. So from the middle, I'm going to go down 1, right 1, down 1, left 1. And this is what my graph looks like so far. It flipped upside down. Okay. And then notice that you have a -4 on the inside here. And that tells you to go left 4 because it's opposite thinking on the inside of the absolute value. So I'm going to move all my points left 4. So I'm going to go left 4 and end up here, left 4, 1, 2, 3, 4, and end up here, and left 4 and the other one end up here. And my graph, my final picture of my graph is going to look like that in blue. All right, so you guys have these topics to do in ALEX. Try them out, and as always, let me know if you have any questions. Good luck.